So here we're gonna talk about this last very important OS related concept, which is the concept of system calls. So we've talked about this figure before, right? So here we have the system's hardware, things like the CPU, the memory, and so on. And on top here, we have the user, which is interacting with the different programs and softwares, right? And in between, we have our middleman or the intermediary layer, which is the OS, which offers a range variety of services, things like I/O operations, process management, file management, memory management, and so on. So when the user program tries to access or request any of these services, it does that using an interface that we call system calls. Therefore, a system call is a programming interface that the programs use to communicate with the operating system to request the services that the operating system offers, right? It is written in high-level language, things like C or C++, right? And we do have the ability to, instead of accessing the system call directly of that operating system, we do have the ability to use an extra abstraction layer, which is the API, right? So the most common APIs here are things like the POSIX API for Unix Linux systems or the Win32 API for Windows. Before we proceed talking about the system calls concept, this is a very important OS related concept as well. It is the concept of dual modes. So operating systems work in two modes, user mode and kernel mode. So user mode is where normal applications run. It's really a restricted mode to prevent users or programs from directly accessing critical system resources. And on the other hand, the kernel mode is where the operating system runs. It has full access to the hardware and system resources. So obviously this separation between the two modes is very important for security and stability. So if an application crashes in user mode, it won't take the whole system down. But in kernel mode, the operating system has total control, so it's used carefully for trusted applications or trusted operations, or what we also call privileged instructions. So we do have something called the mode bit that gets switched on and off to represent which mode the operating system is currently operating under. So let's say we have a user that's currently executing some sort of a process or a program, and then at some point it needs a service from the operating system, so it has to call and use a system call. So as you see in this figure, what happens is we have to switch to the kernel mode, right, in this case, and we, for example, need to switch the mode bit into to 0 to represent that we are currently under kernel mode. So we execute that desired system call, and then we switch back again to the user mode to return to that call-in process. So in this figure, we can see that applications have the ability to access these system calls directly, right? And right here, so you can use and call the system call libraries directly if you are an experienced user, for example. So there are multiple layers, as you can see. If you are less experienced, so you can go a step up here and use APIs as we use, so general libraries, who will in their turn call the specific system call for that operating system. Or if you are a more experienced user, or if you are a kernel developer, you can actually use OS kernel functions directly, right? So you do have the ability to do that if you are if you really are an experienced developer and you know the exact kernel functions to execute. So these kernel functions, as you can see, execute exclusively under the kernel mode, right? But then on the other hand, you can see that the general system calls or the corresponding APIs actually are executed under the user mode. So they don't have the privilege that the kernel functions have. So this is a simple example of the different system calls that are required to execute a simple operation of copying from a source to a file destination, right? So we need a lot of corresponding system calls to be executed in the background. So we need to write a prompt to ask for the input file name and similarly to request the output file name. And then we have to do a search. We have to create the destination file if it doesn't exist, and then we have to start a loop to read from the source and write to the destination, and then the corresponding closing and termination and so on. So there is a series of system calls that have to be executed in the background to simply copy data from a source to destination. This is a simple example. If you are a less experienced user, you don't know the corresponding system call for that operating system that you are working on, you can simply use a standard API to simply read from a file. So the advantage of using these APIs is, again, you get things like the documentation. So you don't know what are the different parameters, what is the expected input for that function. You can simply look at the documentation of that function, right? So here is another figure that simply explains the process of calling system calls, right, and the switching between the two modes. So a user simply requests an open operation, opening a file. So what happens is we are interacting here with the system call interface, and then we are switching to the kernel mode, which in return will try to fetch an array here for the exact location of that system call that will do the open, that will execute the open task for you, right? So you, as a user, you do not need to know the exact system call, right? So the kernel will do that for you. It will fetch it, it will execute it, and then return the result to back to the user under user mode. So there are different, obviously, types of system calls depending on the service that you want. So these are the corresponding system calls for process management. There are some for file management, device management, and other utility type of system calls. Also, there are obviously protection and security type of system calls. So here we see the example that shows the difference between Windows versus Unix system calls. So you can see that to simply create a process under Unix, the system call is called fork, whereas under Windows it's called create a process. So if you don't know the exact system call for that operating system, again, you can use a simple general APIs.